Now, in this video, I'm going to focus on the Riemann sum, the left, the right, and using the midpoint rule. Now, suppose you have an interval a to b. Now, you're going to divide that interval into a certain number of subintervals. Now, your delta x will be b minus a over n. Will be b minus a over n. And then after you get delta x, you're just going to plug that in and you'll have your function there, and you just substitute x1, x2, and continuing like that. Now, let me just give you an example of what this means. Suppose I have f of x equals 2x minus 2, and we are given an interval x is between 2 and 8. Now, and we are going to divide that into 3 subintervals. We're going to divide that into 3 subintervals. Now, the first thing you have to do is get delta x from that. Now, this means that I'm going to use b minus a over n. Then I have 8 minus 2 divided by 3, since it's 3 subintervals. 8 minus 2 is 6. 6 divided by 3 is 2, so I'll have delta x of 2. So I don't know how you do it, but I'm just going to draw a number line. Then you substitute a, the lowest value on that number line. And in this case, the value of a, it's 2. Then you substitute 2 there. Then what you're going to do, you're going to add delta x. You add delta x. So when you add delta x, you're going to have 4. Then you add delta x, you're going to have 6. Then you add delta x, then you have the last value on that interval. Then you have the last value in that interval. Now, suppose you want to calculate the left-hand sum. This is the left and this is the right. Suppose you want to calculate the left-hand sum. You see my n is 3 here. So you start from the left. You're calculating the left-hand sum. The left-hand sum, LHS. You're going to start from the left. You're going to start from the left. You're going to have delta x. You multiply that. You start from the left now. You start from the left, and this is your number of subintervals. Now, starting from the left, I have 2. So you're going to have f at 2. So you're going to have f at 2. Then you continue. Then you're going to have f at 4. Then you continue, and you're going to have f at 6. And that's where you stop. Why? Because it's 3 subintervals. So you only have 3 values there. And that's how you can get the left-hand sum. But now suppose you're looking for the right-hand sum. Suppose you're looking for the right-hand sum. So you'll have delta x into, you start from the right. It doesn't really matter where you start from. You can start here, you can start there. It doesn't really matter. The order does not really matter. The order does not really matter. So you're gonna start from the right. You'll have f at 8. Okay, let me just do this. Let me just use this instead. You're gonna have f at 8. Then you're gonna have f at 6. Then you're gonna have f at 4. And that's where you stop because it's 3. Then you can start here since you want to put things in numerical order for some reasons. Then you'll have f at 4 plus f at 6 plus f at 8. And that's the right answer. But now what if you want to use the midpoint rule? What if you want to use the midpoint rule? Then between 2 and 4, what number lies between 2 and 4? You're going to say 2 plus 4, which is 6, and you divide by 2, then you get 3. You're gonna say 4 plus 6, which is 10, then you divide by 2, you'll get 5. You're gonna say 6 plus 8, which is 14, then you're gonna divide by 2, then you get 7. Or you can get the lowest value here, then you just add delta x. 3 plus delta x, it's 5. 5 plus delta x, it's 7. The point is just to get the first one, then you can add delta x to get the next ones. So the midpoint will just be delta x into f at 3 plus f at 5 plus f at 7. So now let's calculate the values of this given f of x equals this.